Player A versus Player B. Who is the better player? The one with the highest single score or the one who is the most consistent? Statistics don't guess, it calculates. Today, we are completing exercise 11.2 from weighted grades to the median age of a nursing home. We are solving all 11 questions with speed and precision. Let's get to work. Conquering exercise 11.2, a masterclass in mean, median, and mode. Today, you'll become a data detective. We'll solve every problem in exercise 11.2 step by step, and you'll master the essential tools for finding the center of any dataset. Let's begin. The first tool, that is the arithmetic mean, finding the average value in a set of data. The mean is what most people think of as the average. It is calculated by summing up all the values in a data set and then dividing by the number of values. Here x bar is the mean, while the summation of x is the sum of all values in a data set, and n is the total number of values in the data. In question number 1, we need to find the mean by definition. For the first part, we are given ungrouped data, which is 2, 4, 6, 8, 10, and 12. What will the summation of x be? If we add all of the values, that gives us 42, and the number of values is 6. So we know that arithmetic mean is summation of x divided by n. 42 divided by 6 is 7. For the second part, here we have 3, 4, -1, 7, -8, -5, and 0. So if we add all of these values all together, we get 0, but the number of values in this ungrouped data is 7. So 0 divided by 7 is 0. In the third part, here we have the ungrouped data 0, 4, 8, 12, 16, 20, 24, and 28. If we add all of these values up together, we get 112. And the number of values in this data set are 8. So 112 divided by 8 will be 14. So that is our arithmetic mean. For the fourth part, here we have a data set which is U. We have values in decimals. The first is 3.1, then 4.2, 5.3, 6.4, 7.5, 8.6, 9.7, and 10.8. If we take the summation of all of these values, we get 55.6. And the number of values in our ungrouped data is 8. So dividing both of these values, we get 6.95. But if you look at the last part, here we have the data set with the number of values as 8, but all of the values are 5, 5, 5, 5. So when all the values in a set are same, that means that the mean is simply that value. We have 5. If we take the sum of all of these values and divide it by the number of values, we're still going to get 5. For the second part, applying the mean, who is the better batsman? We have batsman A with scores 12, 15, 6, 73, 7, 19, 199, 36, 84, and 29. And the second batsman, which is B, with scores 47, 12, 76, 48, 4, 51, 37, 48, 13, and 0. So if we take the summation of x for all of the values for batsman A and divide that with the number of values given, that will be 48. And that is the average, that is arithmetic mean of batsman A. But for batsman B, the summation of x, which is the sum of all values, is 336, and the number of values is simply 10. Dividing both of them, we get 33.6. So the verdict will be that batsman A has a higher average, which is 48, than the batsman B with the average of 33.6. Therefore, batsman A is the better run getter. Now let's move on to the weighted mean. When some values count more than others. The concept. Sometimes not all data points have the same importance. A weighted mean gives more weight to certain values. Think of a final exam being worth more than a homework assignment. Formula for the weighted mean. It's simply the same as the arithmetic mean, just we add w. Here x bar, it changes to the weighted mean, and the summation of x changes to the weight of each value. Basically, it is the sum of each value multiplied by the weight divided by summation of w, that is the sum of all of the weights. Question number 3. Here we need to calculate the weighted mean for the student marks. Okay, firstly we'll create the WX column, which will be the weights multiplied by the values. We have math, which is 4 multiply 70, so that will be 280. That is our WX for math. Then for physics, that is 285. For chemistry, it is 160, and for biology, it is 55. So basically we multiplied all of the values with our weights. Now we need to take the sum of that. We will take the sum of the weights, which is the summation of w, that is 4 plus 3 plus 2 plus 1. We get 10, and the summation of the wx column, that will be 280 added with 285 added with 160 and 55. So we get 780. Now we will just simply calculate the mean. We have summation of wx over summation of w. So that will be 780 divided by 10, which is 78. Now we will find the weighted means for all of the students. So for example, we did for Hanzala, that is 78. Now we will do the same for all the students like Musa, Zaki and Saleh. So we will get their final weighted means for all students. The mean of group data. How can we find the average when we only have ranges? With group data, you don't know the exact value of each entry. We only know, for example, that 5 items fall between 0 and 5, where 0 is the lower class limit and 5 is the upper class limit. So how can we calculate the sum? The solution is to use the midpoint. We will assume that all the values in a class interval are centered around its midpoint, which is x. This gives us a representative value to use in our calculation. The formula for mean of group data is x bar being equal to the summation of fx divided by the summation of f. F is the frequency of each class and x is the midpoint of each class. Lower limit plus upper limit divided by 2, that is the formula for midpoint. And summation of fx is the sum of frequency into midpoint for all classes, while the summation of frequency is just the total frequency. It is also equal to n, the number of values. Now question number 4, we need to find the mean of group data in practice. Here we have the class interval, the frequency, so we will calculate the midpoint. We will add the lower class limit with the upper class limit, which is 5, divide that by 2, so we will get our midpoint as 2.5. Then we will do the same for all the classes. So we have the midpoint, and we know that the symbol for the midpoint is x. Multiplying our frequency column with our x column, we get fx. So these are the values for each class. Now we know that the total mean of group data is x bar being equal to summation of fx over summation of f. So we will take the sum of all the frequencies, which will be 340, and the total fx, that is 30. The total frequency will be 30 while the total fx will be 340. Now calculating the mean, 340 gets divided by 30 and that is equal to 11.33. For question number 5, which is the detergent packs, here we also have the class intervals in kg and the frequency. So if we find the midpoint, which is by adding the lower class limit with the upper class limit and dividing by 2, we will get our midpoint. After finding the midpoints for all of the classes, we can simply multiply the value of x with f. So we will get our column of fx. The total frequency is 70, while the total fx, which is the sum of all fx, that is 1646. Dividing 1646 by 70, we get 23.51. A new perspective, the median. Median is not the average, but the exact middle value. Step 1, we will order our data. First and most importantly, we need to arrange our data in ascending order from smallest to largest. Then step 2, we will find the middle position, which is n plus 1 divided by 2. This formula will be used to find the position which is the th of the middle value. Identifying the value. Locate the value at the position you just calculated, that will be your median. Another tip is that if n, which is the number of values, it is even, then the median will be the average of the two middle values. So in question number 6, we need to find the median in ungrouped data. First example will be the data set with an odd number of values, and the second will be the data set with an even number of values. So for the first example, we have a data set which is not sorted at all, that is 1, 4, 2, 5, 3, 7 and 6. Sorting it in ascending order, we get 1, 2, 3, 4, 5, 6, 7. Now, what is the number of values in this ungrouped data with odd number of values? It is 7. So we can just use the formula n plus 1 divided by 2. 7 plus 1 is 8. 8 divided by 2 is 4. So this does not mean that our median is 4. This just represents the position. Now looking at our data set, the fourth value is simply 4. So that will be our median. In the second example, we have a data set with even number of values. Firstly, we have this ungrouped data, which is 0, 1, -2, -3, 4, 5, 6, and 3. Sorting it, we get -3, -2, 0, 1, 3, 4, 5, and 6. So the position, the n, which means the number of values, that is 8. So we can just add 8 plus 1 divided by 2. That will be the 4.5th value. This means we average the 4 and 5th values. So the median will be 1 and 3. If we add them together, we get 4, and 4 divided by 2 is simply 2. So our median will be 2. And finding the median for even number of values in ungrouped data, the formula will be 1 by 2 bracket n by 2 th plus n plus 2 divided by 2. Question number 7 and 8. Median and mean from the frequency table. In question number 7, we need to find the median in a frequency distribution. We will need a cumulative frequency column to locate our middle position. Okay, so first, if you look at the class interval, that is the radius, our frequency is denoted by x. So what will be the cumulative frequency? For the first column, it will just be 6, but for the second class, it will be 9 added with 6. That means that the cumulative frequency for the second class is the frequency of the second class added with the preceding class. The total frequency, which is the summation of f, that is 132 after we added all the values of the frequency. To find our median position, we will just use the formula n plus 1 divided by 2. 132 plus 1 divided by 2 is 66.5. That means our median position is in this value. If you look at the cumulative frequency, we have 6, 15, 30, 54, and then 87. We know that 87 is a greater value than 66, so we will go below it. But below the values, we have 54, 30, 15, and 6. So this will be our median position. We will know that our median lies in this class. Looking at the cumulative frequency column, the 66.5th value falls within the group where the cumulative frequency goes up to 87. The radius for this group is 1.0 and the frequency for this group is 33. Question number 8. Finding the mean age. This is a reinforcement of the mean for group data. The summary of totals. The total frequency we get from the table is 31 and the sum of fx we get from the table is 1965. Dividing both of them together, we get 63.39. That will be our answer for question number 8. And for question number 7, we know that our median position lies in this class interval where the cumulative frequency is 87 and the radius is 1.0. The final tool, which will be the mode, it is simply the most frequently occurring value. For ungrouped data, we have 2, 8, 4, 8, 3, and 8. If you look closely, this is the easiest one to find. Just scan the data set and you will identify the number that appears more often than any other. That is 8. So that means we have one mode in this data set. A data set can have one mode, more than one mode, or no mode at all. If a data set has one mode, then we consider it as a unimodal data set. If a data set has more than one mode, like 2, then it is bimodal, and if it has 3, then it is multimodal. And if there is no mode at all, then there's simply just no mode. For group data, we can't see the individual values. So first we identify the model class like we used to identify the median position in group data. The model class is the class with the highest frequency. And then we use a formula to estimate the mode within that class. Here the formula is L plus F subscript M minus F subscript 1 divided by 2F subscript M minus F subscript 1 minus F subscript 2 into H. We'll define these variables when we apply the formula in question number 11. For question number 9, for the first part, we need to find the mode in the raw data. We have 1, 2, 3, 4, 5, 6. You will notice that each value appears only once, so there will be no mode. In the second observation, we have 2, 4, 2, 3, 2, 5, 3, 2, 5, 4, 2. You will notice that the numbers 2 appears 5 times more than any other, so the mode will be 2, and this is an example of a unimodal data set. In the third example, we have 120, 130, 140, 225, 125 and 225. If you look at the observation, you will notice that 225 occurs both times, same as 120. That means this is a bimodal data set. In the fourth raw data, we have 2, 4, 3, 5, 5, 3, 4, 2. So we can notice that 2 and 2 occur both times. We have 5 and 5, they occur both times, 3 and 3 occur both times, and 4 and 4 occur both times. So this is a multi-model data set where the modes are 2, 3, 4 and 5. They are all appearing twice. Question number 10, mean, median and mode. Here we have our frequency distribution table with the class interval 0 to 5. The frequency is given as 3, 5, 9 and so on. We need to find the value of fx, which is just simply the class interval multiplied by the frequency. So that will be 0 for the first class, 5 multiplied by 1 is 5, 9 2s are 18, 4 3s are 12 and so on. Now we find the cumulative frequency. If you notice that for the first class interval it will just be 3, but for the second it will be 5 plus 3, which is 8. Then for the third class it will be 9 plus 5. So finding out all of the cumulative frequency of the table, we will notice that the highest frequency is 9. If you look at the frequency table, the class interval with the highest frequency is 9. We won't look at the cumulative frequency. So calculating the mean, the summation of f, which is the sum of all frequencies, that is 24, and the summation of fx is 48. Divide that two values and we will get our mean as 2. What if we want to calculate our median? The total frequency is 24 and we know that the position of the median will be summation of f plus 1 divided by 2. So we know that it will be the 12.5th value. Using the cumulative frequency table or the column, we will know that the 12.5th position falls between the group where x is equal to 2. Finding the mode. If you look at the highest frequency in the data, which is our model class, it will be 9 and it corresponds to the value of 2. So that means our mode will be 2, which appears more times than any other. Question number 11, the final challenge, the mode of group data. Here we have a problem. We have the classes 1 to 4, 5 to 8, 9 to 12, 13 to 16 and 17 to 20 with their frequencies. So we need to find the mode of this. We will firstly identify the model class, and that is the class with the highest frequency. So the third class is the class with the highest frequency, which is 10, and its class interval is 9 to 12. Now we will define our boundaries. We talked about this formula earlier, but we didn't define the variables. Here L stands for the lower boundary for the model class, and Fm is the frequency of model class, F1 is the frequency of class before, For example, the third class is our model class, so here f1 will be 8, and f2 is the frequency of the class after, which will be 6, and h is our class interval size, so you can calculate it by subtracting lower class limit with lower class limit of the preceding class, and that is 4. Now we place the values and solve, so we will get our mode as 10.33. Now for part B, we have the model class given as 10 to 15 and its highest frequency is 7. We need to find the mode of the group data. We will again use this same formula and place the values. For example, the value of L, the value of F subscript M, the value of F subscript 1, F subscript 2, and the value of the size, which is the class interval size. So you will get your mode as 14.375. You've mastered central tendency. You've successfully navigated every challenge in exercise 11.2. You can now calculate the center of a dataset in three powerful ways: for raw data, frequency tables, and group distributions. This is a foundational skill for understanding the world through data. Now let's make a short recap. What is the mean? The mean is the average value. It is best for symmetrically distributed data but sensitive to outliers, which are huge amounts of data. The median is the middlemost value. It is excellent for skewed data or when outliers are present, as it's not affected by them. And the mode is the most frequently occurring value, the only measure that can be used for categorical data and useful for identifying the most common outcome. Exercise 11.2 done. You are now a master of central tendency. If this helped you clear your homework, hit that like button.